for P6-11, the body. We're not real sure, but based on the spacing, kind of thinking that these bolts are going to act as retainers. Might be a no-ring groove sealing surface, but realistically, this is this geometry. Without knowing exactly what it does, we still have questions that need to be answered. So let's go with revolve. I could do all of this geometry. We could create the cylinder and then the internal geometry. We can do all of the geometry at once. It's kind of a toss-up there. So I still want to stay with the revolve. I don't think the whole wizard is really helping me here, based on the variety of geometry, kind of the say kind of custom geometry that we might be dealing with. So let's try the S key this time, doing the little down arrow, going to center line, infinite length, vertical. And again, just anything that gets a revolve, right click and select to get out of it. And then L on the keyboard. We had a diameter of 36, so I'm not trying to hold it too close, but maybe a little bit pretty close on the size. So the upper has a diameter of 22 down to where the threads start, so there's a clearance there. So whatever this is doing in sealing, not really a sealing surface, that would be a lot closer. And then to figure out the minor diameter of an M20 by 2, also makes the math easy. We're going to take the pitch of 2 and subtract it from the 20 and end up with 18. So that has a little bit of a step. And then we're coming down to the lower surface. And that one actually shows a ledge there, but we're not really detailing that. So based on just drilling that, I think we'll bring it over some angle and bring it to the distance. All right, so let's start off with the 36, and that'll automatically scale. Our overall height is 100 millimeters. So let's escape, get out of the diameter, apply the length. So that's going to stretch out quite a bit. There's a 4 millimeter step below the thread, but without having that that internal diameter, I'd rather just take the tap drill and go ahead and plunge. I don't, again, without having good functionality there, it's kind of hard to decipher. So between, we'll assume a 118 degree drill point, so 59 degrees. Could also be 135, but to be on the safe side, the 118 is a little bit longer. 135, if we were to measure to that shoulder and get it pretty close, would just leave a little bit more on the depth. And our main function here is to make sure it's not breaking out. That if we were bringing this down as close as we could get to the far wall without breaking through, then we want to take that into consideration. All right, so we said that our tap drill was going to be an 18 millimeter, and if worst case, if I find that that ledge, whatever purpose that ledge serves, is critical, I can always go back and put that in. So they're showing a thread length of 28. So back in diameter, we'll hit escape, put in the 28, and Since the 4 millimeters is part of that, I probably want to include that. I think when I did this last time I ended up with an offset, but I don't remember it being 4 millimeters or so. And then the top is going to be the 22 millimeters. And let's see. And nothing really for the depth, so we're probably, we have the from there to there, and I didn't have to get out of the diameter because I picked between the two objects. So I think we're just going to take our numbers, 21.5 plus 24 plus 28 plus 4, and see what that gives us to the step. All right, so basically just taking our numbers, our stack up of numbers here, the 21.5, the 24, the 28, and then going to the shoulder of the drill bit, not to the point, should bring us pretty close to that location. Again, the ledge that I'm talking about is we're not given a diameter there, so I don't know. As far as the ceiling surface, maybe it's the same as this lower. If we calculated the 3 millimeter, so M20 3 millimeters per side, maybe that's 14 millimeters. But until I know what it is, I'm going to leave it and come back to it later. It doesn't really help us with the tap, and really I want that thread engagement as much as possible so that the tap can get in there. I'm assuming that I'm going to probably I'm gonna tap this as opposed to trying to do an internal threading. Even threading on a CNC is going to be kind of difficult, almost 3 inches deep. All right, so that gives me my my revolve information. We'll go ahead and accept that. All right, so we have 2 possibilities here for the M6x1 threads. I will go ahead and show the 3D sketch, and my preference is to create a plane and have a higher level of control than maybe the whole wizard 3D sketch can give. Sometimes the 3D sketch just gets a little bit weird. I would rather have multiple features that I have higher level of confidence in, and just try to stay away from the 3D sketches. All right, so the straight tap, ANSI metric, bottoming tap is fine, and M6x1, and up to next is okay. With our positions, if we pick a point, or we pick the cylinder, I can tell that I'm in a 3D sketch because I have this exaggerated origin reference, and my icon goes to XY. That is the plane that I'm in. If I hit tab, let's see, because I picked a cylinder, it may not tab, but it should go to YZ and XZ. And when I place this point, I'm placing that point on the cylinder. So if I hit escape, that point is free to move and will stay pointed towards the inside, but it's a little bit strange to work with. So we'll put this first one on the front plane. So select and control select the point, and then that will be make on plane. So that at least locates it. Now getting the dimension, this one is 41.5 from the top. So let's see if I can pick a location. So kind of a weird angle there. Let's see, from the origin maybe. Nope, still got that that strange angle. So let's see, Control 8. We'll go from the top ledge. See if it likes that. Nope, still looking for the center of the circle. So let's rotate over. I'm going to hit the S key, find a center line. Let's just make the center line from there to there. Alright, so that got coincident to the edge. That stays coincident to the point. Alright, so 41.5, we get it there. Can't say that I like dimensioning those, so we'll go ahead and accept it and put it in place. In contrast, when we go in to create a plane, there's an extra step, but I know that I can count on that plane. So easiest way to make a plane is to highlight, so in this case the right plane, and hold down the control button. I'm looking for that four-headed arrow, and I'm just going to drag away. So I know the distance would be for a 36 millimeter would be 18, but I also have this second reference that if I were to pick the cylinder, no, I do not want it to be perpendicular. I want it to be parallel, and I want it to be tangent to that face. If I flip the offset, it goes to the other side, and we accept it. Now we have a plane that our hole wizard will act normally. So the other option would be to go features, reference geometry plane, and I think even in the S key we can get down to the reference geometry in the plane, so one of those will work for you. With the plane selected, I can go S key and hole wizard. We're using the same M6x1. We'll go into positions. In the 3D sketch, I use the front plane for to make on plane to center this. In this case, I'm going to go vertical to the origin, and we're going to be, because the circle is projected into this sketch as a line, I don't have to worry so much about it finding the center. And we go 21.5 and accept and accept. And we'll go take a look at that. I am ready to hide my plane, and we'll make sure to save that as I think we'll just call it a body. All right, so if I look at this with the hidden lines visible, which is the same as coming over to the pull down, to the display pull down, and selecting hidden lines visible. The if you haven't customized it, that's going to show us that internal geometry, and maybe doesn't look exactly, but we're close enough to get it started. All right, so on to the assembly. I just realized that did not put the threads on the internal. So we're going to rotate over to where I can see that inside edge. Select it. We'll go up to Insert Annotations, Cosmetic Thread. So if this was a hole wizard, it would have already produced those for us. So an M20x2. And then let's Control 1. I'll go back to Display. And not really getting a preview. So up to next, and we'll go ahead and see what it generates. So pretty much all the way to the bottom. I don't know that we can get all the way to the bottom, so I would prefer, since the threads on the hex bolt were generated at 23, thinking that we're probably going to be better off with a blind in condition, and instead of the 32, telling it a minimum of 25. So from a manufacturing standpoint, we always drill a little bit deeper than what we need. And then when I tap, I'm pretty much going to tap until the tap bottoms, until I can't tap it any deeper. So that will get us that reference. And if I come over to the configurations, add configuration, go back to the solid thread. And if you don't add the configuration, it's not really going to hurt. We're going to see it more so in the drawing. We're going to have a lot more geometry maybe than what we would expect. Okay, so the thread tools. This is from the edge. Let's offset it upwards. And we're still on the M20. This time it's going to be a metric tap. And in condition, blind, 25 millimeters. Okay, about the same as the cosmetic. And then if I reverse the offset so I have one thread starting above, and maybe go a little bit deeper just for reference to 27. My last thread still ends about 25. And this being a cut thread. And again, it's removing material. And we'll go ahead and accept. And we can see those threads internal in the part. So let's go identify cosmetic thread. Okay, so hide that. I think it's confusing to have both of them showing at the same time. So if I have that one turned on, and okay, so that one's turned on, and in the solid thread it's turned off, that will help. And we'll make sure to save.